So, hello friends. Today we are going to study the same topic which we have studied in the last class, importance of folic acid in our life. And in the last class we have studied the folate, how the folate cycle works, what is the synthesis of folic acid in the bacterial body, and why in our body folic acid is not synthesized. So all those things we have studied in the last class. So that's why we need to know the application of this folic acid. In the last class, if you remember, we have came to the CH2THF. This is a coenzyme, and from folic acid to CH2THF we have studied in the last class how it is happening. But now what we are going to study, from the CH2THF, how this coenzyme is very important for the synthesis of DNA, for synthesis of new life in mother's womb. So all those things we need to know, and that's why we all know that whenever a lady got pregnant, doctors or nutritionists especially, they always suggest the folic acid tablets. I still remember one of my close friend's wife, he also takes the folic acid tablets. So that's a very important thing for humans evolution, human life formation. So folic acid actually works in the DNA synthesis. DNA we have studied in the last class also, the DAMP synthesis and DTMP synthesis. What is those? This is deoxy adenosine monophosphate, this is deoxythymidine monophosphate, all those things. So what are those? So first we need to know that what is the structure of that coenzyme, what we have studied in the last class also. Just go and check it out. The structure of the CH2THF coenzyme is like this. Okay, just there will be a cyclic structure of 6-member ring, CH2, another cyclic structure, double bond O, NH2. So this is the basic structure, and with that there will be an NH and the R. Okay, so what is the R? The R of the folic acid. We have studied this ring comes from the PABA, para-aminobenzoic acid, which actually stays in the bacterial body, not in human body. So that's why bacteria forms the folic acid, and this is, we all know, glutamic acid moiety. So this is the structure of CH2THF, right? And in this CH2THF, particularly this is the CH2, and this is the actually THF means tetrahydrofolate. So this is actually folic acid moiety. These positions become like those are hydrogen bonds were there. So those positions is hydrogenation happened, and that's why this became tetrahydrofolate. And here the extra CH2 came. This CH2 came in from the serine moiety. We have studied in the last class. The serine becoming glycine plus HCHO, and this HCHO is attaching with the folic acid and giving this tetrahydrofolate CH2. So CH2THF. This is the structure of CH2THF. So now what we will do, we will just shortly like the last reaction we have studied. Several reactions happens in our body, and to produce the coenzymes from folic acid to tetrahydrofolate to the coenzyme. So each only one type of CH2THF there? No. there are 6 different coenzymes, and all those happens by different processes. I am just writing down the structures of CH2THFs. So first, of course, what we have studied, I will try to draw all the coenzyme structures. Sorry. So this is, we came to know, so this is the folic acid moiety, and this is, so this is CH2 plus NHR, and R equal to, we all know that R is this. CH2 CO2 minus. So this is the R. So this is 1. Now what is the second one? Second one is this. Is this no? So what actually happens for the second one? This nitrogen attacks here and this open up. So that produce actually the second one. Right? So when the structure will be done, you will come to know. And what will be here? Here will be the same double bond row, the same NH and the NH2. Here also there was in NH2. Okay, so this is the second structure. What is the third structure? Here comes the third structure. So actually all those actually help the body to produce different DNA parts. Like here actually the NR, NH, and here what happens? This CHO, H double bond. So this actually happening here. And the same NH2 stays there. So you can see that this part, all these parts actually varying in different coenzymes. Other parts remains as same as it's possible. So this is the part, if I need to write it down, this is the part what is varying. Okay, again we'll draw the third one. So what will happen here? The CHO moiety will be attached with this, nothing more than that. NH, R, the NH2 and NH. Okay, so this is it. So again the changing part is the same, this part. Okay, going to the next one. So just draw the structures with me. That will help you to understand the whole point of seeing a molecule. Okay, so if you don't draw a structure, you can never get attached or get passionate about that. Okay, this is the fifth one, the same structure with different part, this. And the last one, maybe I'll draw in the red also. What will happen here? This CH double bond NH, and here will be NH R. So again, which part is changing? This part is changing. So this is the 6 coenzymes. Okay, so these 6 coenzymes, here is the 3 coenzyme, number 1, number 2, number 3, number 4, 5 and 6. So these 6 coenzyme actually helps us to synthesis of thymidine, to synthesis of adenosine moiety, to synthesis of uracil moiety, to synthesis of the guanosine moiety. So all those things actually done by those structures. How? So today we will learn that. So the topic is now thymidylate synthase enzyme. Thymidylate synthase enzyme. Okay, so this is the topic. Now see, in our body there is deoxyuryl monophosphate, like this structure. I am not going in detailed structure, but you all know that will be a very big structure. Just I am drawing the uracil moiety. And in our body, this is the thymidylate synthase enzyme, which have a sulfur or SH, maybe it's from serine or something else. So deoxyuryl monophosphate, this is, and this is the thymidylate synthase enzyme. Thymidylate synthase enzyme. So what will happen? The sulfur of these will attack. This is a Michael acceptor, you all know this is a Michael acceptor. So it will attack here, it will open up and it will go. And what will happen? There will be the formation of another very interesting moiety. So the S. Now the double bond will be open up and it become OH. And that OH, and there will be a double bond. So here in our body there is no absence of bases in our body, so there will be a base. We will take up the hydrogen. Maybe I can show it in the different color. So the base will take the hydrogen, this will open up and this will attack. Which will it attack? It will attack that CH2 which is changing in the previous coenzymes. Okay, so it will attack the coenzyme CH2. How will it look like? So let me see. Which enzyme will we take? Maybe we are taking this enzyme number 5. This we are taking. So you will draw with that color which we have drawn earlier to make you understand more clearly. So there will be like this. No, so what we are taking? We are taking this. Okay. So the second one. Okay. So the second one we are taking. It is occurring here, and the rest of the part will open up. I am not drawing the whole structure. Okay. So this is the structure which changes in every coenzyme. That's why I am drawing that structure only. So it will open up, and after opening up, it will give rise to the coenzyme substrate. That will be a match, the coenzyme substrate. So what will be that structure? That structure will show like this. The NH, so this CH2, this is the CH2 with which it will attach to the coenzyme NHR, blah blah. I am not drawing this. So there will be a double bond O, and here will be of course a hydrogen. So there are bases in our body which will take the hydrogen. Why? Because this hydrogen is very acidic. Okay, this is the alpha. So this is the alpha hydrogen with respect to the double bond O. That's why this is acidic. So it will open up, and after that, maybe in a different color. Yes. And this is also. To see what is happening by these coenzymes, this CH2 is transferring to the DULT by the folate cycle. Whatever is happening, the total folate cycle actually supplying this CH2 moiety, this CH2, only the CH2 moiety, and this CH2 is very important for our body. Why? Without this CH2, no deoxythymidine will be there. Okay. So to produce the thymidine, without thymidine no DNA will occur. To produce the thymidine, GCH2 acts as a very important coenzyme by attaching with the THA. Okay. So this is happening. Now what will happen? Eventually the coenzyme part will go, and here will be the double bond O, N, and here will be the S. This double bond CH2 I will show in different color. Maybe that will help us to remember that this CH2 comes from the coenzyme. Now what is happening? Now there will be the N minus. Okay, so this part breaks. So when this breaks, there will be the N minus, NHR, and there will be these things. I am not drawing the full structure. So what will happen again? This N will be attacked here. I should write it more properly so that you can understand it. NHR. So here will be N minus. So it will go, the hydrogen is here. This hydrogen will attack here. You know? So after attacking this hydrogen here, what will happen? This will go like this and this. So there will be another structure occurring. So without writing, you will never get understand those things. So this is actually the beauty of this subject. If you write it out, this is very simple, just like drawing the jigsaw puzzle. You need to just put all those things, and there is will be the double bond. Okay. So now what will happen? Now this OH will break down, it will here, and this serine will go out. This sulfur will go out, and there will be this molecule. So this will be the molecule of our interest, and this molecule is known as deoxythymidine monophosphate. So this is the DTMP, and this is a very important molecule, because without this thymidine monophosphate, the sugar backbone will not occur. Okay, the sugar backbone is made by the phosphate, and this thymidine will be there. It will bond with the adenine thymidine bond. So the total DNA will break down if this thymidine is not generating in our body. And how this thymidine will be generated in our body? By the folate cycle, this CH2 or this CH3 comes up. So this is the very important CH3 part. Okay, so we have came to know about all those things, and again there will be another reaction by which there will be the formation of AMP and GMP. So I will try to write it down also. What will happen there? Like this. So there is the CONH2 group and NH2. So this is a moiety in our body. So this NH2, again write it down in the another form. This NH2 will attack the C double bond OH in R and the coenzyme part. The NH, there will be NH. I'm not writing it down again. So this is the coenzyme COH, and it will attack here. It will open up. Eventually, it will give rise to the another beautiful structure, and that is like this. Sorry. Let's write it down in black. It will be like this. Sorry, there will be a double bond also. Here will be a double bond also. NH2. So the folic acid used as a marker which carries the CH2 of serine to the thymidine, right? So this is the CH3 marker in the previous. So here it will do the same thing also. NH, and here will be a big structure like this, and this. In R, all those things. I am writing this up. So here there will be H, there will be OH, and what will happen? The OH will give rise to opening up of this, and by this process what the structure will come up, right? So this CONH2, there will be NH, double bond OH. This nitrogen lone pair will attack here, and it will open up and again give rise to structure like this. CH2N NH this. So it will give rise to this, and of course everywhere there that will be attached to the DNA part. So this is DNA. This is DNA. So this will give us adenosine monophosphate or guanosine monophosphate. So it will give rise to this, and here also you can see this actually giving rise to this, then this carbon and that carbon actually helping us to development of this C carbon, and this is coming from the folic acid. So what I have tried to show here, that without folic acid we can never ever we can get the AMP or GMP or any other thing, or TMP. Previously we have studied in the previous class or previous page, that TMP. So all those things is coming up from the folic acid, and that is how folic acid actually helping a new life, a new born baby. He needs new DNA, and this DNA will form when that TMP, DMP, AMP will be present, and that is how the cell proliferation will occur, the new DNA synthesis will occur, the process of central dogma, DNA to RNA to protein, that will not break down, because DNA will be going on by help of this deoxythymidine monophosphate. So all those things actually summing up that without folic acid a newborn baby may have some defects, some DNA defects. That's why doctors or nutritionists, they suggest the folic acid to the pregnant women, because a pregnant woman is delivering a newborn baby, he is giving birth to a new life in her womb. So that is why the whole thing is going on, that folic acid is very important for synthesis of adenosine monophosphate, guanidine monophosphate, thymidine monophosphate, which will help us to grow from inside and to grow from outside. That's it for today. Thank you. Stay healthy, stay safe.